SEC Weekly is to merge our enthusiasm for what we watch unfold on the playing field with the amazing achievements that are taking place in the classrooms. One professor in Tuscaloosa has a similar challenge. He's studying balance, specifically how it's affected by the inner ear. Dr. Craig Formby has developed the Rototilt chair, a one-of-a-kind invention that rotates, twirls, and eventually spins test subjects head over heels. This device allows researchers to gather data on how the inner ear contributes to balance and why that system sometimes goes wrong. For more, here's a story from the University of Alabama.
The inner ear, in particular, has got different sensors that can test whether a person is moving up all of a sudden. We test acceleration as in an elevator. When you step on the gas in the car, you get thrust backwards in the seat. We've got sensors inside our ears that actually are telling us that we're being pushed forward at a certain with some acceleration. This chair can excite those sensors individually, is what we're trying to do. So we've got pairs of these sensors, two sensors that do the up-down motion, two sensors that do the fore-out. And so we'd like to be able to excite just one side but not the other. And so if we can assess the person's behavior during some tests and say, you really should be behaving in this way, but you're not, then we can tell that person this sensor's failing you. And so we can better look and diagnose what kind of problems they might be having. But what we can do in this system is we can also test when you have this spin going around. Sometimes there are defects or there are problems inside the inner ear that are occurring. We can bring them to new positions and have a very good idea of where these particles are. And in some cases, not only diagnose the problem, but also treat the problem.
The way we determine whether someone's having a problem with our chair is to actually record our eye movements, which we record with infrared high-speed goggles. So we can see the eye movements that arise in response to stimulation of the vestibular system. Our camera's actually monitoring his eye movements now. We've got in the trace below, we can see the horizontal and the vertical canal, or vertical eye movement response. So the red tracing is showing the vertical eye movements, the up and down eye movements, and the horizontal eye movements are shown by the blue tracing. The eye movements would be provoked in the position where the semicircular canal is being activated by these debris. And what we would be looking to see is that the nystagmus, or the eye beating response, would diminish over time. It fatigues out when it's in the provoking position, and when the response fatigued out, we'd move to the next position. So we went through a set of positions there, and we would expect in the non-provoking positions we wouldn't see any eye movement responses at all. And we'd bring them back, and we might repeat this again to make sure that we had a successful treatment. The plan is, once we have all the engineering aspects of the chair largely worked out, then we'll probably move over to the med school here on campus, and then we'll be able to offer both clinical and research opportunities. And because the chair will be unique here and around the world, I anticipate we'll have opportunities to bring in clinicians and patients from other places too to share. So it'll be a shared resource with researchers and clinicians in the community at large.
Ahead on SEC Weekly.